Good morning, guys. In this video, we'll start off with the problems based on Laplace transform of derivatives. First problem, t sine square t. We should find the Laplace transform of t sine square t. So, in last video, we have learned that Laplace transform of t into f of t is equal to f dash of s minus f dash of s. So, first we'll find what is the Laplace transform of sine square t. Then we'll find the derivative of that Laplace transform. So here, Laplace transform of sine square t. This sine square t can be written as 1 minus cos 2t by 2. So I can take this half outside the Laplace transform, and Laplace transform of 1 minus cos 2t is 1 by s. Laplace transform of 1 is 1 by s minus Laplace transform of cos 2t is s by s square plus 2 square, that is 4. So after taking LCM and all, we'll have 2 by s into s square plus 4. What is this? This is Laplace transform of sine square t. So Laplace transform of t into sine square t will be minus of d by ds of this Laplace transform. So you can see in the last video, we have proved that t into f of t, Laplace transform of t into f of t is minus d by ds of f of s. Here f of s is 2 by s into s square plus 4. So if it is t, then we'll be differentiating this once and we'll be multiplying this by minus 1 to the power 1. Suppose it is t square, then we'll be differentiating this twice and multiplying this by minus 1 whole square. So here they asked for t sine square t, so I am differentiating this once with respect to s and multiplying by minus 1. So differentiation of this is, I've used quotient rule while differentiating this. So here it is u dash v minus uv dash. U is 2. So u dash is 0 minus u 2 into v dash. So it is s into s square plus 4 ka derivative. So it is, see when you expand this, you will get s cube plus 4s. So s cube's derivative is 3s square and 4s derivative is 4. And this minus I have multiplied it here. So that has become plus divided by v square. U dash v minus uv dash divided by v square. So it is s square plus 4 whole square. So this is the Laplace transform of t into sine square t. So we'll move on to next problem. T square into e power minus 2t minus cos 2t plus 4. So first we'll find what is the Laplace transform of this. And then we'll find what is Laplace transform of t square into this. So Laplace transform of e power minus 2t is 1 by s plus 2 minus Laplace transform of cos 2t is s by s square plus 4 plus Laplace transform of 4 is 4 by s. So this is the Laplace transform of this bracket. So when you want to find the Laplace transform of t square into this, you need to use the theorem, that is minus 1 whole square d square by ds square of this function. So minus 1 whole square is plus 1, and when you differentiate this once, say I have written d by ds and I have differentiated this once. So derivative of this with respect to s is minus 1 by s plus 2 whole square minus, again here I have used the quotient rule. So this is u and this is v. So I have used u dash v minus uv dash divided by v square. So u dash means derivative of s is 1. U dash v is s square plus 4 minus u is s, v dash is 2s divided by v square is s square plus 4 whole square. And derivative of 4 by s is minus 4 by s square. Okay, I have just expanded this and simplified this. You get 4 minus s square. And again, differentiating this with respect to s, you get this. Okay, so this is the final answer of this Laplace transform of t square into e power minus 2t minus cos 2t plus 4. So here also again have used quotient rule, and I have expanded the bracket just to simplify it. Okay, and this is a simplified form. So next problem, Laplace transform of t into sin 3t into cos t. So first we'll find what is Laplace transform of sin 3t into cos t. Okay, so we know that sin a cos b is half sin a plus b plus sin a minus. So using this formula here, Laplace transform of sin 3t cos t will be equal to Laplace transform of half into sin 4t plus sin 2t. So Laplace transform of sin 4t is 4 by s square plus 4 square. That is a by s square plus a square. Here in place of a, we are having 4. And similarly sin 2t is 2 by s square plus 2 square. So Laplace transform of sin 3t cos t is 2 by s square plus 16 plus 1 by s square plus 4. I have taken this half inside. So it looks like this. And finally Laplace transform of t sin 3t cos t will be minus into derivative of this. So here also I have just used quotient rule. Okay, so this is the final answer. Yeah, we'll move on to next problem, Laplace transform of t into e power at sin at. So first we'll find what is e power at sin at. Laplace transform of e power at sin at. Since there is exponential here, we'll find what is sin at first. Laplace transform of sin at is a by s square plus a square. When you add exponential to that, you know that Laplace transform of e power at into sin at will be, so you will just replace s by s minus a. When there is an exponential multiplied to the function, you will replace s by s minus a. A here is the coefficient of t here in the exponential. So it is a by s minus a whole square plus a square. Here I have just expanded this. And here, now finally Laplace transform of t into e power at sin at will be minus derivative of this with respect to s. So that will be 2a into s minus a divided by s square plus 2a square minus 2as whole square. Okay, so moving on to the next problem. See here, since it is a constant, you can just take the derivative of 1 by s. What is the derivative of 1 by s? It is minus 1 by s square. So here, similarly, I have written the derivative of this whole thing as minus a by this denominator square into derivative of this. Derivative of this will be 2s minus 2a. Or you can just use the quotient rule, one and the same. You'll get the same answer. Okay, you can use the quotient rule. Okay, moving on to the next problem. T cube into e power minus 2t. First, we'll find what is Laplace transform of e power minus 2t. It is 1 by s plus 2. T cube means, according to the formula, it is minus 1 whole cube, and the third derivative of this 1 by s plus 2. So here I have written the first derivative, it is minus 1 by s plus 2 whole square. And again here I have written the second derivative, minus 2 by s plus 2 whole cube. And finally here it's a third derivative. So it is 6 by s plus 2 whole power 4. So next problem, I think this is the fifth one. Yeah, finally. Yeah. So what is this? T square minus 3t plus 2 into sine 3t. So first we'll find what is Laplace transform of sine 3t. Okay, then we'll find what is the Laplace transform of this with the x polynomial. Okay, Laplace transform of sine 3t is 3 by s square plus 3 square, that is 9. Now t square into sine 3t. First we'll find what is Laplace transform of t square into sine 3t, then minus 3t into sine 3t, and this will be same as sine 3t. So Laplace transform of t square sine 3t will be, since it is t square, we'll have minus 1 whole square, and second derivative of this 3 by s square plus 9. So derivative of this is, first derivative, minus 3 by s square plus 9 whole square, and derivative of this s square plus 9 is 2s. And again differentiating this with respect to s, I have used quotient rule here. So considering this as u and this as v, and using the quotient rule, u dash v minus uv dash divided by v square, we have this, and this is a simplified form. And next, what we want 3t sine 3t. So that will be, see this 3 I have taken it outside, and t sine 3t will be minus 1 whole power 1 d by ds of Laplace transform of sine 3t, that is 3 by s square plus 9. And derivative of this is minus 6s by s square plus 9 whole square. So on simplifying, we'll get this. So finally, Laplace transform of t square minus 3t plus 2 into sine 3t will be equal to, see I have just used all these result in the final equation, and I have written the final solution. Okay. So we'll move on to next one. Prove that integral 0 to infinity e power minus t p cube cos t dt is equal to minus 3 by 2. We know that integral 0 to infinity e power minus st t cube cos t dt is equal to Laplace transform of t cube cos t. See here, this is see according to the definition of Laplace transform, e power minus st ft dt is Laplace transform of ft. In place of ft, I am having t cube cos t. So it is Laplace transform of t cube cos t. So don't think that s is missing here. It is e power minus t. In place of s, I am having 1 here. What we'll do here is, we'll find what is Laplace transform of t cube cos t. And then in place of s, we'll be substituting 1. And we should prove that the thing is minus 3 by 2. So here, as we did in previous problems, first we'll find the Laplace transform of cos t, then find its third derivative, and then multiply by minus 1 whole cube. So Laplace transform of cos t is equal to s by s square plus 1. So Laplace transform of t cube cos t is equal to, this is equal, minus 1 whole cube, third derivative of s by s square plus 1. Now what is its first derivative? See here again I have used the quotient rule. So after simplifying this, we'll get this. Okay, and again using quotient rule, I have done this. That is u dash v minus uv dash divided by v square I have used here. And at last again I have used quotient rule. So in each and every derivative, I have used quotient rule. So this is the final answer what I'll get. In this, I have substituted the s as 1 here. In place of s, I am having 1 here. Remaining everything is same. So in place of s, I need to replace 1. So here in this step, I have done that substitution. There's see, this is actually integral 0 to infinity e power minus st t cube cos t dt. Now I need just e power minus t cube cos t dt. So I can do that by replacing s by 1. So in this step, I have replaced s by 1. So after simplifying, we'll get minus 3 by 2. Similarly, we'll take the next problem. Prove that integral 0 to infinity t into e power minus 2t sine square t dt is equal to 1 by 8. See here in this problem, we are having 2 in place of s. Anyhow, first we'll write the standard form. Integral 0 to infinity e power minus st t sine square t. We have just clubbed the t terms one side. T sine square t dt is equal to Laplace transform of t sine square t. So first we'll find what is Laplace transform of sine square t. Okay. See in sine square t, I can write that as 1 minus cos 2t by 2. So Laplace transform of t into this will be minus d by ds of Laplace transform of half minus Laplace transform of cos 2t by 2. Okay, Laplace transform of half is 1 by 2s. See, you can also take this half outside and you can write what is Laplace transform of 1. 1 is 1 by s. So half is half by s or it is 1 by 2s minus. See here we have taken this half outside. Laplace transform of cos 2t is s by s square plus 2 square. It's equal to, here in this step we have taken half outside. So now differentiating this with respect to s, I have, see what I have done is I have taken this minus inside. So first term will be s by s square plus 4 and the second term will be minus 1 by s. So using a quotient rule, u dash v minus uv dash divided by v square, using that formula we'll get this. And differentiation of this 1 by s is minus 1 by s square. So this becomes plus 1 by s square. So now Laplace transform t into sine square t will be so much. Okay, after simplifying this, it will be so much. But I need 0 to infinity e power minus 2t, not minus st. I need e power minus 2t t sine square t dt. So by replacing s by 2, I have, see here when I replace s by 2, no, this whole term will vanish. So the remaining thing will be 1 by 4. Since there is half outside, we'll get 1 by 8. Okay. So this is all about the second problem. Yeah, next problem. By using the Laplace transform of cos at, find the Laplace transform of sin at. So what they have given? By using the Laplace transform of cos at, find the Laplace transform of sin at. So we'll take f of t as this cos at. Okay. And Laplace transform of that cos at is s by s square plus a square. And we know that when you differentiate this f dash of t, no, that is cos 80, will sin 80. Okay, so f dash of t is minus a sin 80. And I know Laplace transform of f dash of t is equal to s into Laplace transform of f of t minus f of 0. We have proved this. So, using that result, Laplace transform of f dash of t is equal to s into Laplace transform of f of t minus f of 0. And what is f dash of t? It is minus a sin 80. So that we have written. It's equal to s into Laplace transform of f of t. F of t is cos 80. Laplace transform of f of t is s by a square plus a square. That we have written. This yes, I have written it as it is. And Laplace transform of f of t is s by a square plus a square. So it is s by a square plus a square. Minus f of 0. See, f of t is cos 80. So f of 0 will be cos 0. Cos 0 is nothing but 1. So here the constant minus I have taken it outside. And here after taking LCM, no, you'll get like this. S square minus a square divided by a square plus a square. So this plus a square minus a square will get cancelled. And you are left with minus a square by a square plus a square. But here there is another minus here. That minus, this minus will get cancelled and a will get cancelled. And you are left with a by a square plus a square. So actually this is the Laplace transform of sin 80, right? So using cos 80, this is how we will find the Laplace transform of sin 80. Okay. So this is all about this problem. We'll move on to next one. Obtain the Laplace transform of t sin 80 by using the rule for the Laplace transform of second derivative. So you know what is the rule for Laplace transform of second derivative is Laplace transform of f double dash of t. So this one also we have proved is equal to s square L of f of t minus s into f of 0 minus f dash of 0. This is the rule for Laplace transform of second derivative. That is Laplace transform of second derivative. Now, what they have given? Obtain the Laplace transform of t sin 80. So, take that t sin 80 as f of t. Okay. So, now you just differentiate that twice. You will get f double dash of t. So, f dash of t is, you should use product rule here, t into derivative of sin 80 is a cos 80 plus sin 80 into derivative of t is 1. And again differentiating this with respect to t, here you should again use product rule. Okay. So here you will get, see, a into, okay, t into minus sin 80 into a. So that is how we'll get minus a square t sin 80. And keeping this as it is, a cos 80 into derivative of t is 1. So a cos 80 into 1 plus derivative of sin 80 is a cos 80. So this two terms are same and they will add up to 2a cos 80. Okay. So using all these things here in this formula, we'll get Laplace transform of f double dash of t. What is f double dash of t? It is minus a square t sin 80 plus 2a cos 80. That I have written equal to s square into Laplace transform of f of t. What is f of t? T sin 80. That is what we have to find here. Laplace transform of t sin 80 minus s into f of 0. F of t is t sin 80. F of 0 is 0 here. T is 0. So it is 0. Here I have it. And f dash of 0. Where is f dash of t? This is f dash of t. F dash of 0 here, see this t, here if I substitute 0, this first term will vanish. And here if I substitute for t as 0, sin 0 will be 0. So f dash of 0 is 0. So now you are left with, see I have just split these terms. Minus a square Laplace transform of t sin at plus 2a, here it is constant, 2a is constant, I have taken that outside, and Laplace transform of cos at. That is equal to s square into Laplace transform of t sin at. So these two terms are 0. Okay. Here, what I have done is I have taken this to the right hand side, because here also I am having Laplace transform of t sin at, and here also I am having Laplace transform of t sin at. So I have taken this to the other side. So if I take that as common, I'll be left with s square plus a square. And this side, I'll be left with 2a into Laplace transform of cos at, or s by s square plus a square. This is the Laplace transform of cos at. And once I cross multiply this, no, I'll get 2as by s square plus a square whole square. That is Laplace transform of t sin at. Okay. So this is all about the problems based on Laplace transform of derivatives. Thank you.